Good evening once again, ladies and gentlemen, and welcome to those of you who have just joined us following our AGM for tonight's technical lecture, which will be on pollution incidents and response and will be presented by Hazel Christie. Before I introduce you to our speaker, I would just like to run through a little bit about how the Q&A session will work. We'll be having a Q&A session at the end of the lecture, and you'll be able to ask your questions in one of three ways. You can raise your hand and we can then promote you to panelists, allow you to speak. You can ask your question, any other questions you'd like to ask. But because this lecture is being recorded, you will also appear on the YouTube video. So if you don't want to appear on the YouTube video, you can either type your question into the Q&A chat or into the general chat box, and we will read your question out at the end of the lecture, and then Hazel will answer your questions. Sharing. So our speaker tonight, as I said, is Hazel Christie. Hazel works for the MCA, and she completed her BSc in Environmental Science at Plymouth and went on to study Marine Environment and Resources MSc in Bordeaux, Bilbao and Southampton. She worked as a scientific diver and marine scientist before joining the MCA in 2015, and whilst initially working in policy development within the marine technology branch, she then moved over to the counter pollution and salvage team as an environmental scientist advisor. So I'd like to just invite Hazel now to unmute herself, share her video and share her screen. It's always good to know that the speaker has stayed. So if you could share your screen.
Yeah, no problem. Thank you so much, Lizzie. And I will try to do that.
The little green share screen button at the bottom.
Yep. And hopefully it will remain stable throughout the course of this presentation. Can you see my screen?
I can see your screen. Thank you very much.
Great. Wonderful. Wonderful. Okay, so good evening, everybody. I hope you've had a great day and enjoyed the AGM, and welcome to this presentation. My name is Hazel Christie, and as Lizzie said, I work in the Maritime and Coast Guard Agency's Counter Pollution and Salvage team as the Environmental Scientist Advisor. My contact details are on the screen, so if you think of any questions or you've got any follow-up questions, then feel free to get in touch with me after this meeting. I work in planning for and responding to incidents, so I don't work too much with policy anymore, and I'm certainly not a MARPOL expert, but my focus is more on how a response might benefit from scientific inputs like producing oil spill models, standing up something that we refer to as an environment group, to produce sensitivity maps and advice, and keeping an eye on things like satellite imagery that we receive on a regular basis. For this presentation, I'd like to set the scene a little bit before I go more in depth into some recent specific incidents, and to touch upon some of the plans currently in place, some of which you can find online and read all about at your leisure if you are interested. I'd also like to talk more about the pollutants themselves and discuss a bit more about how they vary. Ships are by no means the only source of pollution to the oceans, but this would be a rather lengthy presentation if I were to try to cover everything. And I certainly won't cover all the incidents that I've been involved in, but there are two that I'm going to talk about at the end of the presentation, which will provide context. There are also some historical incidents which are very noteworthy, and I'll give them a brief overview, but there's a wealth of information out there and you may be familiar with them already. So I'll just highlight how the response approaches and techniques have evolved and talk more about how that impact has shaped UK counter-pollution response today. I can provide plenty of links via Lizzie or in the chat after as well, if anyone would like. So I will hopefully give you a bit of insight into what the environmental science people are doing in the background, and hopefully move on the slide. There we go. So to set the scene a bit, as I'm sure you're aware, there are quite a few ships that transit around the UK, and it's very easy to look up vessel positions on freely available vessel tracking sites. And these sites will also give an idea of the different types of ships that are present, and they pose different risks. And while the key phases of response could be similar, things like search and rescue is obviously our main priority when it comes to the Coast Guard response, the salvage response and the cleanup of the pollutant that's present. Responding to a tanker spill, for example, could differ to a container loss, and there would be different environmental considerations. On average, there are 170 incidents per year. So whilst I haven't got any graphs on here, but pollution incidents have decreased over the years, both in terms of total incidents and also the quantities of oil pollution. They do still occur. There's an organisation called ITOP, which some of you may be familiar with also, and they produce some statistics on this, and they've got some really good graphs on their website, and you can look that up if you're interested. And that's international as well. So it covers the UK as well as what's going on around the rest of the globe. Looking at the UK again, we also, from an MCA perspective, we also recently commissioned a review into the risk and likelihood of serious hydrocarbon releases from vessels. And that's the image that you can see there. That's one of the snippets from that report. There is, I believe, an executive summary, but that's going to help inform future counter-pollution response strategies in the UK going forward. So those vessel releases, they actually represent less than 25% of all marine pollution sources. However, it's still something that does obviously need to be recognised. Offshore installations, we have around 300 oil and gas installations around the UK, and the MCA isn't the regulator for these. That would be the Offshore Petroleum Regulator for Environment and Decommissioning. However, the MCA would lead on the response to the pollution at sea if there were a spill to take place. Land-based spills can also occur, and whilst the MCA would support in the response, it may not be the lead authority in these cases either. So we'll go back to vessels, and the UK has suffered about 3 of the world's largest recorded spills to date, which I'm going to go on to talk about now, or after this slide. So there are a few plans available to help try to mitigate the pollution threats that are present. So just to list a few and give some sources where you can find more information about the response set up in the UK and how the different players coordinate. At an international level, there's the Bonn Agreement, which covers the North Sea and its approaches with 10 contracting parties. And there are also bilateral agreements with France and Norway, known as Mancheman and Norbrit, respectively. And as party to UNCLOS, so the United Convention on the Law of the Seas, and signatory to the OPRC Convention, which is the International Convention on Oil Pollution Preparedness, Response and Cooperation. So I'll just refer to it as the OPRC going forward. The UK has an obligation to protect and preserve the marine environment. So the MCA is the custodian of the UK's National Contingency Plan, and it's described as a strategic overview for responses to marine pollution from shipping and offshore installations. And this is a document that is one of the measures the UK has taken to meet this obligation. Its purpose is to ensure that there's a timely, measured and effective response to incidents. So all of those plans are available online. There are other plans present. There are things called Oil Pollution Emergency Plans, also known as OPEPs, for the offshore industry. Ports and harbours have pollution plans because of their obligation under the OPRC Convention, and these are audited by the counter-pollution and salvage officers based in and around the UK and in the counter-pollution team. Local authorities also have shoreline plans. Some of these can be found online because they have an obligation under a different act, the Civil Contingencies Act, to plan and prepare for emergencies. So some of them might be held with that particular authority, but some of them can also be found online. So there's a lot of plans that are available, and a lot of plans literally all over the place. But as you're well aware, seas move, so that cross-boundary coordination and cooperation is very important, and it's needed on many levels. When thinking about shipping pollution, most people think about oil spills, and no doubt these are certainly problematic, and this is evident from incidents and international preparedness efforts in things like the OPRC Convention. But oil fate and behaviour in the marine environment will also vary a lot between different oils and also under different conditions, as lighter ends are more likely to evaporate or disperse quicker and therefore could affect the water column, whereas more heavier oils may form a more persistent slick and be more problematic for things like seabirds or shorelines. The cargo on board vessels can be very variable as well and pose different risks, obviously. So containers can have a lot of different contents by their very nature, and also potentially hazardous cargo. Fishing materials can lead to entanglement or ghost fishing, and we've seen several incidents of marine timber, which clearly they've got a risk for navigation, which is definitely problematic, and other vessels, but can also form this kind of slick, as you can see in the image in the bottom right there. So when it's in large quantities, it can actually cause a kind of smothering effect on intertidal areas. The vessel itself is also going to pose a pollution risk, and there could be other onboard chemicals which could pose a risk to the marine environment. So now I'm going to talk about the three rather significant spills that have happened in the UK. And some of the lessons learned. So kicking off with the Tory Canyon back in 1967, which, if you don't know, ran aground off the coast of Cornwall with the loss of many seabirds and many other marine organisms, sadly. And it really was the first major oil spill from a vessel. So the response was not as well practiced as it might be today. And we'll go on to talk about the modern response and the efforts to clean up the spill in the later incidents. But with the efforts in this particular case, the response employed may have done more damage than good, such as using industrial degreaser to disperse the water, the oil in the water, and used in very, very large quantities directly onto the shoreline. We've now got ecotoxicology assessments which are used, and there are standards applied to dispersants prior to their approval to assess, making sure they're not more toxic than the oil itself, for one, what quantities they need to be applied in, and how they work on different oils, and if they're actually effective in dispersing the oil. There was the Brer back in 1993, and that ran aground off the coast of Shetland and prompted the development of a report by Lord Donaldson. And this led to the provision of 4 dedicated emergency towing vessels around the UK, of which we still have one based in Scotland. There wasn't really an at-sea response for this incident due to the weather and the oil type, because it was quite a light crude and it broke up quite quickly because of these conditions. But because of that, we did learn a bit more about how best to respond and basically try to salvage the vessel before it does sink, because this light crude, because it did break up quite quickly, it you know, obviously still affected the water column. Number 3 was the Sea Empress, and it ran aground in Wales. There was another report by Lord Donaldson on this, and it led to the creation of the SOSRAP, which is the Secretary of State's representative for Maritime Intervention and Salvage, and the recommendation of the Environment Group to provide advice to the different response cells. There was a big response necessary for this one, obviously with 72 1,000 tonnes of crude oil lost, but it was quite a successful example of how dispersants can be used, because it was quite a slow release. So with the fresh oil, when dispersant was applied, it was quite good at breaking it up as it was released. Before I go into the two different recent case studies, I will discuss the time of the incident. However, I won't go into all of the players involved and all of the notifications that took place. But for awareness and for background, if you aren't familiar with it, the UK operates a parallel command structure. So if an incident occurs or during an exercise, for example, there isn't one commander in charge of the whole response. Instead, there are these different cells for different aspects of the response. For example, the source control, which would be led by the SOSREP, and the ATSI would be led by the MCA, and the shoreline response would be led by the relevant shoreline authority. The different cells would work together and be supported with advice from the environment group or the scientific and technical advisory group, depending on if it's looking at the ATSI piece or if it's more of a public health issue, as well as information from other representatives, such as the vessel or the salver. The notification process for marine pollution would be that the reports that are received by the Coast Guard would then go to the duty counter pollution and salvage officer, and also the duty scientist, who would then in turn contact the appropriate stakeholders and affected parties. So that would be myself or my boss. It can get a bit complicated, so I hope I haven't lost you yet, but I've provided some background, and with that I will crack on with two of the case studies, and hopefully it will all make a bit more sense. Back in December 2017, there was a spill overboard from a bunkering operation. However, the Coast Guard wasn't made aware until the following morning, so there was a slight breakdown in the notification procedure there. The polluter didn't inform the Coast Guard, and we found out actually because the fishermen had reported oiled nets. We were then able to investigate further and find the source. The weather conditions, they weren't great, so did hamper any at-sea efforts to recover any oil. And because we weren't able to mobilise the aircraft to assist in the location of the oil and also gain a quantification, it was quite tricky. You can see here the image on the left is one taken from a vessel, and you can see just how poor the visibility is, sort of, because it's not a very good image either. It's quite hard to get a good image to show poor visibility. And the other image shows a sample taken, which was the HFO that was spilt. And this was rather important because the sample analysis meant that the shoreline responses from the local authorities that had been affected along the coast were able to recover their costs. This is because of chromatographic analysis, and it can identify different biomarkers in the oil, almost like a signature. So you can identify the specific polluter. If you can find the source, then you can follow that lead. But despite the first reports of only about 50 litres that were lost, the oil affected quite a large area of the coastline, all the way from Selseyville to near Brighton, I think. So all over Sussex, and it took about 3 weeks to clean up, and they recovered about 45 15-kilogram bags of oil and oil debris. So why mention this? It seems like a relatively small spill, but I feel like it demonstrates where satellite imagery has been incredibly valuable in response. And this is an image taken of the area and outlines of the polygons that you can see in the right-hand image where the potential slick has been detected. Satellite imagery works using synthetic aperture radar, which detects a flattening of the capillary waves or abnormalities in that on the surface of the water. So there are varying levels of confidence in that when it comes to whether if the seas are very rough, it's more difficult to detect, and equally if the seas are very calm, because it can't then pick up that flattening. If there's wind shadow, it can come up as a darker patch, similar to where an oil slick may be present, but it can pick up those darker patches, and that might be where a potential spill has taken place. We are able to task satellites in the UK via we've got a contract with a commercial provider, so it takes about 24 hours, 48 hours to actually do so, but it does cover quite a large area of the UK, and we get 2 passes per day. So we do get those images and the detection with the confidence levels. So we are able to use that and hopefully identify if there is a slick detected, and then we can use that along with AIS data and compare the two and try to find out or interrogate the vessel and find out what's happened, if anything has happened. If you look at the left-hand image as well, you see the white spots. I don't know if you can see my cursor, you probably can't. But the white spots basically represent the vessel. So that's a hard, flat surface. So that means the light is reflected versus the grey area. So in the left-hand image, the island that you can see on the left is the Isle of Wight, and you can see there's a cluster of smaller boats just to the west of that. That's a little bit about how satellites work. With those satellite images, not only can it help with at-sea response, it can also help with oil spill modelling that we'd be doing in the background. So there are a few types of oil spill models that we would conduct. So predominantly, I myself would be using deterministic modelling. So we'd be looking at oil trajectory over time. So we would hear about an incident that's taken place. We'd know the spill location, hopefully. We'd know the quantity and the type of oil, because these will vary, and the computer model would be able to take that into account. If we've got all that information, then we can have more confidence in the output. However, if we're a bit scant on details, that means that perhaps the output we would have less confidence in. So garbage in, garbage out, that is something that's commonly referred to. There is another type of modelling called stochastic, which is the probability of impact, and that looks at basically the likelihood of something impacting. So it takes a lot of scenarios over several different incidents, and that's used for planning. So the likelihood of an oil spill, if it were to occur from a particular location, then that can be factored in, and sometimes you see that in some of the plans. It is possible to do hindcasting as well, looking back in time, so we can plot a course and say there is oil here, and where did it come from. However, if we don't know the release time, or if it's a shoreline impact, if we don't know where or when it landed, then that can be lower confidence as well. Some of the limitations around the modelling that we do is the wind forecast and the current forecast. Again, if we don't have that information, it's very difficult to have a high level of confidence in the output, because it's only as good as the weather forecast. So we have a MetOcean download link that we can use, and the algorithms in the computer model does its own calculation thing, and it's very clever at doing that. Also, the oil type and quantity is sometimes quite difficult to assess, but if we do have that, then hopefully, if we've got all the correct information, the outputs can correspond to the trajectory, so where it might go, but not only that, also the behavior. So I mentioned oil types can differ. That heavy fuel oil is probably going to be a more persistent slick, and it's less likely to spread out than something like diesel, which we'll touch upon next. So it's perhaps going to maybe coat the shoreline, maybe stay together as a slick more, but we can use the polygons as referred to in that satellite imagery, map that into the software and adjust as we go along, as the weather forecast and things like that change, and that can be used to support the area of surveillance. So this is the MV Kami, which ran aground in the Minches. So once all the notifications are in hand, with the GT counter pollution and salvage officer and the SOSREP doing their thing, the duty scientist is also working away here in the background. And in this incident, there were different pollutants present. The oil type here is diesel, so again, it's more likely to disperse in the water column, and it wasn't in enormous quantities, but still obviously a concern. But the main, or one of the key considerations was the cargo of 1,927 tons of solid recovered fuel pellets. And this is what you can see in the lower image here, which are a mix of basically everything. So it's used in energy systems and furnaces to recover fuel. But that could be plastic, wood, paper, glass, textiles, metals, other organics, all in these kind of pellets. So this is the same sample of the same cargo, and you can see just in the color of the water how different the composition might be, because we really didn't know. And the plastics contained within the cargo of this particular incident would have had a really, really detrimental effect on that particular location. It was also an incident that happened on the first day of the first lockdown. So doing it remotely was quite interesting. If you want to know more about the incident specifics, then you can look up the MAIB report, and I can share the link if you would like. Thankfully, because there was a grace period where the weather conditions were quite calm, there was a possibility of setting up this kind of chain of removal whereby the cargo could be lifted out and transported on various barges for disposal prior to dismantling in Kishon. The aerial surveillance for this provided some great images, because it was a remote situation, and it was really useful to see that, especially if we're based in Southampton. But if anyone is interested, we do have aircraft that we use for at-sea surveillance on a regular basis, and we've expanded our capabilities in recent years. So after the bunkering spill, and they do come with a suite of technology, including long wave, infrared and ultraviolet line scanners for pollution detection and quantification, and also detection finding for VHF, UHF and EPUB transmissions. If you want more information on the spec of those, then we do have the MCA counter pollution stockpile document, which details all the spec there, and I've placed the link within that slide. So Kishon, I would like to credit for this, and hopefully you can see it. It's just a time lapse, it's just a 1 minute slide, but it shows a little bit more if it works. That is, if it doesn't, then I will happily share the YouTube video. It may not work. I think I'll probably pause that and then carry on with the slides, and then maybe share the link afterwards. But if you look up the Kishon port dismantling, there's a nice time lapse, and it shows the damage of the vessel that had occurred when it did run around, because you can't see it too clearly in this particular image here in the top right there. So with that particular incident, I've talked about the aerial surveillance side of things. So that was really key, especially with it happening remote. We had a lot of remote telecons, including the group that is the environment group. That's something that I myself might be setting up. So we have a standing environment group in peacetime, which develops plans and has several meetings and discusses any particular changes in their region. So that's the map that you can see on the right hand image there. They also provide advice through their core membership, and each of the devolved administrations has its own GIS mapping software, which can provide different GIS layers for environmental sensitivities, shoreline types, a lot of different information, historical sites, that sort of thing. So that's a couple of examples there, but they are again freely available online. The core membership of the environment group, so once an incident happens and we do get that notification, would be the statutory nature conservation body, the relevant fisheries authority, and the waste regulator. And once they come into the environment group, they would obviously be bringing their expertise in their particular field. However, they would then be representing the environment group. So there's one consistent line of advice that can then be provided to those response cells to advise on, is it suitable to place the Kami in this particular place of refuge, for example. So they're going to be providing guidance to all the response cells. So not only that, the SOS rep would like to know about the place of refuge, where to mount shoreline response as well, because we will be inputting the spill modelling. So we'd hopefully know a little bit more about where that pollutant, that oil, is going to be heading. With the Kami, it was quite interesting as well, because where it grounded, it was quite close to islands that are uninhabited, that have been rat-free and were very sensitive because of the presence of seabeds. So biosecurity was one of the things that was considered in reference to the Kami. And there would also be, I've put dispersants in here, and it wasn't a consideration for this particular incident. However, it is something that is often discussed and often on the standing agenda, because it could be something that the environment group would be discussing. And that's because dispersants, whilst I mentioned they would break up the oil, disperse it in the water column, there is the consideration about, is it going to affect seabirds more or fish more? As a very simplistic way of looking at it, there's obviously more considerations to be made. But there's a lot of things that the environment group is going to be discussing, and it can be expanded as well. So the core membership of those three key players, it can be, if we are talking about seabirds, it might be that JNCC or the various SPCAs are getting involved. If it's closer into shore, then it could be that public health bodies are invited to attend. And or equally, if it looks like it's going to affect fisheries, perhaps food safety might also get invited to attend. So with that scene setting in the UK, there are still pollution risks present, but with all the different plans in place, the training exercises that we do, hopefully if something happens, response efforts follow, as you have seen in those recent cases, and are successful. It's not necessarily just as easy as booming around the vessel or picking up the litter from the coastline. There's also some science going on in the background too. I hope you found the presentation useful, and I wasn't telling you lots of things that you already know. If that's the case, then I hope you enjoyed a little refresher. Thank you very much to the organisers, and thank you for listening.
Thank you.
Are there any questions?
For a very interesting lecture. As you say, people do have the opportunity to ask questions now, and we'll give them a little bit of time to ask those. I will kick us off. I have a question, which you may or may not be able to answer, but how do we compare?
I'll try my best.
Like, in terms of our preparedness, in terms of the techniques and technologies we're using, are we performing well compared to other countries? Are we a world leader in this, or is there more that we could be doing to improve versus other people?
Was that how do we compare to other countries? Right?
Yeah, exactly. I mean, rivals France, for example, we work with them, but
yeah.
When we learn from them and they learn from us, but are we sort of well matched, or is they doing more or less than us?
It's quite difficult to answer that, really, because we have quite a few dispersant stockpiles, for example. So being more of an island nation, with France having a smaller coastline, they do have a few they've got their own dedicated towing vessels along the north coast of France, but we work closely with them. So the Coast Guard in the UK can then call upon the Abais, the tugs over there for support. And that's why some of those international agreements and accords are in place, because perhaps dispersants could be used in, you know, in other waters. And we've had very recent exercises with Norway to test Norbrit as well. And it would generally be a case of working together. When it comes to capabilities, there may be some countries that have more. There's the European Maritime Safety Agency, EMSA, and after Brexit, they did move the, you know, their resources out of the UK. However, EMSA does sit on the Bonn Agreement. It's one of the contracting parties, the EU is, so EMSA would be able to potentially provide support in that situation.
Thank you.
So it's difficult, though. Long-winded way of saying it varies depending on the incident.
Okay, so someone has asked a question. Have you been involved in any prosecutions of vessel owners for pollution incidents?
Yes, not me personally, but there have been incidents. So if you think of the satellite imagery, there was a case, I can't remember the year, it was a few years ago now, but basically they were able to prove there was a discharge of tank washings within 12 nautical miles, and they could identify the vessel using that satellite imagery, and there was a successful prosecution after that.
Interesting. Does anyone else have any further questions in the meantime? You do have a thank you from actually our new council member, Susan Harland, has thanked you for a great.
Thank you.
It's very kind of you. Is there anything else from anyone at all? Yes, there is. Someone has asked anonymously, unfortunately, but for instance, such as the solid pellets or for cargo loss, it's not reasonable to expect every last pellet to be collected. How is an acceptable level of pollution decided?
Oh, again, that's another tricky one. It would be, we have, if you think about cost benefit analysis, so there is another term which, when it comes to cost recovery, or in terms of how clean is clean, if you're thinking about a term like that, are you doing more environmental damage than good? Or are you being technically unreasonable in trying to source that pollution? So technical reasonableness, that's outlined, I think, in the CLC convention, and you have to assess the potential for response, and are you using appropriate techniques to actually collect it. So we'd want to minimize the oiled material collected, because that has its own environmental knock-on effects, as well as the cost implications. So if you're recovering, if you're thinking about tar balls on a beach, for example, and you start going in with, you know, a digger, or you're going around and getting every single teeny tiny little tar ball along a beach, but you're recovering an awful lot of sand, that waste then has to be treated. So some key considerations: are you doing more damage than good? What are the regulations in place? Because so the Kami, for example, that is in Scotland, so they've got slightly different licensing requirements to the rest of the UK, and that may have an impact. So they might want every seabed deposit, which wouldn't include the cargo necessarily. However, it would include something like the vessel itself. So if there is a seabed deposit, they would then require that removal if it's reasonable to do so.
Thank you. We do have a question about, do you deal with air pollution at all?
Not in our team. However, NOx and SOx is something that's dealt with our Cleaner Seas team, so that's the more policy-based side of things. So if you've got any questions around that, I would be happy to take them away with me, but I might not be able to answer them right now.
Okay, thank you. Someone else has asked about the Tory Canyon incident. Do you think about why the vessel ran aground?
I don't actually know. It was before I was born. So I don't know, but I'm sure it'll be a very
I think a quick Google's probably going to answer that one, isn't it?
Yeah, I think it was just poor navigation. I think it was poor navigation, but I'm not entirely sure, so don't quote me. Sorry.
Wikipedia is our friend. So according to, it was a navigational error, and she hit a rock near the Isles of Scilly, and didn't have a scheduled route and didn't have full-scale charts of the Isles of Scilly. So no wonder she hit a rock. Basically, yes. And someone has also mentioned that there might have been steering failure, because apparently there's something called the Tory Canyon device, which must do something to do with steering. Okay, are there any more questions at all? I'll just give them a couple of minutes. I'll just briefly make a couple of announcements. So as I said at the start of this lecture is being recorded, and it will be uploaded to our YouTube channel in the next few days. When we advertise our next lecture, which is going to be on the Sweeter Frontier, which is the world's first liquefied hydrogen carrier, we will also include the link for the YouTube video. And Hazel, I'll send you the link as well so that you have it. So as I said, we will announce the next lecture in the next few days. We'll also be posting things on our LinkedIn group, so please join that if you can. I'd quite like to get us up to the 1,000 member mark, where we're getting there. We're quite close now. So if we can just push us over that would be a nice milestone to achieve this year. Something to mention at next year's AGM, I suspect. So there are no further questions. So I think I'll just give a final thank you to you, Hazel, for your time and for an interesting lecture. Thank you to all the attendees for your time as well, and for attending. And I do hope you will attend our future lectures. And so nothing else to say. I wish you all a good night, and yeah, and stay healthy and happy, and